Estimating sums and differences, page 171, lesson 4-1, October 28th. Skip anything. We are right on task here, right on target. We're good. Estimating sums and differences. First of all, why do we estimate? Again, we've had this question probably. If I were to estimate how many times we've had this question, maybe about 1,000. Sydney. Yeah, you need to estimate when you're shopping. You need to estimate in the real world so that you know how much money you have to spend. Why do we estimate for math class? Since you guys are all about the right now, you know, you're not going to the grocery store right now. You're right here in class. You're sitting down. You're taking notes. Why is it important for that you learn this skill for today? Yeah. Absolutely. Well done. Yeah, we need to know about where our real answer should be. And we talk about sums and differences in regards to adding and subtracting. What do you do if your answer isn't matching up with what your estimate says? Something's wrong. Something is wrong. Maybe you did something wrong. Maybe you didn't copy the problem down correctly. That's usually what it is. You didn't copy the problem down correctly or something. So anyway, so we look at, we're working with fractions. And we're going to be using something that's called a benchmark. And according to the definition on 171, a benchmark is a number that is close to a fraction and is easy to use when you estimate. So when we think of fractions, and if we say a benchmark for regular fractions, we are going to use 0, half, or 1 whole as our benchmarks. What do I mean by a regular fraction? What comes to mind when you hear regular fraction? Yeah. Not an improper, which would mean what? What's the relationship between your numerator and denominator in a regular fraction? Yes. Right. The numerator, top number, is going to be smaller than the bottom one. Okay? 4 over 7. 9 over 11. Okay? Regular fraction. Okay? Not improper. Very good. So when I use these benchmarks, okay, you'll have, so let's use, here's 3/8. I want to estimate for the fraction 3/8 to determine, is that fraction closest to 0, closest to half, or closest to 1 whole? Now, what's key here is for each of these, using the same denominator that you already have. What does 0 look like in a fraction form with 8 as the denominator? Yeah, 0/8. What does 1 whole look like with 8 as the denominator? Kishana. Over the 8s? The 8, right, which would be 1 over 1 if you simplified it. Now, how about the half? How about the half? Yes. 4. Okay? So knowing that, if I'm working with a 3/8, I need to say, is it closest to 0/8, 4/8, or 8/8? And we would definitely say that this 3/8 is closest to. Therefore, I would round to half. You know what? That's definitely closest to half. I'll use half for the 3/8. Okay? Now, when you have a denominator that's even, it's actually pretty simple. So if I were to even use, like, how about 11/12? I was going to say, all right, I need to round this 11/12. I'm going to use my benchmarks 0, half, or 1. So again, 0, that's easy. That's 0/12. 1 whole is easy. That's the same as the denominator. How about half with 12 as a denominator? Trinity. So I look at the 11/12. Is there 11/12 closest to 0/12, 6/12, or 12/12? So I would probably round that to what? 1 whole. Okay? So I'm going to go through all that. And for the assignment today, they'll say, okay, I'm going to give you 3/8. I'm going to have you add it to 11/12 to see what we get. Well, we already called 3/8 half, and we called 11/12 1 whole. When I add half to 1 whole, I get 1 1/2. We just estimated a sum. What do we do if you have a fraction that does not have an even denominator? So if we said 13/15. To estimate or to round for 0 is easy. That's always easy because that's always going to be a 0 on top. To estimate for 1 whole, that's always going to be easy because it's always going to be the same. Now, half, if I go back and look, it was always half of what the denominator was. So for when I had the 8s, the 4, right? Half of 8 was 4. For the 12, half of 12 was 6. Worked out well because they were even, easy to cut in half. However, when I've got the 15, what is 15 cut in half? And you cut 15 in half. Joe, 7.5. So technically, 7.5, 7.5 is what half is. Now, some people that are very good with cutting odd numbers in half might just go with that decimal and say, yeah, 7.5. Other people might say 7.5 for me means 7 or 8, somewhere in that range. Okay? If I were to kind of go, if I were to go down 1 from the denominator and say 14, half of 14 is 7, go up 1, 16, half of 16 is 8, 7 or 8, somewhere in that neighborhood. Okay? Where does 13/15 fit? 0, half, or 1 whole? Definitely would fit as a whole. Okay? So I'm going to have you try a couple and see how you can use this skill. So do 5/13, do a 4/25, and do an 11/20. Any thoughts there with the 5/13? Anyone go 0? Anyone go half? Anyone go 1 whole? Sarah, I said half. I'd have to agree with you there. Yes. Okay. Because what is half of 13? 6.5, right? That 5 is definitely closest to the 6.5 than it is to 0, right? How about the 4/25? 0, half, or 1 for the 4/25? Definitely 0 there. Half for 25 is 12.5. That 4 is much closer to the 0. It's only 4 away from the 0, where it's 8.5 from the 12.5. And the 11/20th? Definitely half. 10/20ths give you half. The 11 is right there. Okay. Any questions there? Now those are for regular fractions. Okay, so for regular fractions, we use 0, half, or 1. Okay? Mixed numbers are a little bit different. Mixed numbers are a little bit different, but the concept is still pretty much the same. For mixed round to the nearest, looks like nearest, round to the nearest whole. So if you have a mixed number, you're not having any halves at all. You'll be using half to determine whether you're going to round that up or if it's going to just be the whole number you started with. When you round any time, say you had 4.6, 4 and 6/10, and I told you to round to the nearest whole. What would 4.6 or 4 and 6/10 become? 5? How did you know it was 5 and it didn't say it 4? What was the rule? What was the magic that turned it into a 5? Josiah. Five or higher. 5 or higher. Good. As a fraction, what fraction do you think of when you think of 5? Or 0.5? Half. So if your fraction that's attached to your whole number and your mixed number is half or greater, you can round up. For example, 3 and 3/5. If 5 is your denominator, what's half of 5? Half of 5, 2.5. Does that mean this 3/5 is bigger than half? Yes. Therefore, it rounds to 4. Okay? If this 3/5 were just a regular fraction without the whole number, you might say it was half. But because it's with the whole number, it's a mixed number, and that's what you got. 2 and 2/9. Does 2/9 represent a fraction that's half or larger? So the nearest whole here would be what? Just a 2. 12 and 19/40. 19/40 represent half or larger. Just under half, therefore, stays at a 12. Okay? So anytime you've got these fractions that you're working with on your mixed numbers, they have to represent a value of half or larger to round up. Okay? Four and 2/9 plus a 6 and 13/27. We're just going to take these concepts and just put them into simple addition and subtraction problems. 4 and 2/9 rounds to 6 and 13/27 rounds to equals. There it is. Nine and 8/15 minus 3.5. 9 and 8/15 rounds to 10, because half of 15 is what? 7.5. The 8 is just bigger than the 7.5. 3.5? 3 or 4? 4 equals 6. Any questions there? Look on page 173, please. As you look at numbers 1 through 12 on 173, are there any there that you think would cause you major problems if you had to do that on your own? Knowing what you know. And they're broken down. 1 through 6 is just the regular fractions. 7 through 12 are the mixed numbers. So a little bit different rules for each. And they separate them so that you can hopefully remember. Look at 11. Just look at 11.